So in this lab that you're going to be doing, we're going to be using this projectile launcher. Pretty simple. It's a tube. It has a spring in it. You can set it at whatever degree you want, and the degrees are marked. Now, you have like a little wooden dowel. That's what we shoot. Washer on a string. That's what we use to hold the dowel in place and to fire it. We just push the dowel in there, slide the washer in one of the two slots. It doesn't matter which slot you use. The only thing that's really important is you use the same slot all the time for the entire lab. So you have the projectile in the tube. We want to set it at whatever angle we want to fire it at, say 30 degrees. It goes on the ground. We want to hold it down and just give the washer a good sharp, good quick tug, and it'll fire out just like that. Now, the things that you want to do, and the procedure says to do this, we want to measure how far it goes. That's how far from the shooter to where it hits on the ground. I don't care about the roll. That's not the important part. It's how far it goes in the air. The other thing is you want to time how long it's in the air from when you fire it to when it hits the ground. That's pretty important. The last thing, and I don't know if it says this in the procedure, but we're going to just assume that this is at ground level. And so we're going to make the assumption that time up is equal to time down and work by that type of problems. Now, we're going to take a look at I want to run through the procedure real quick and look at a little bit on the data sheet, and then that's really all you need to know for this lab.
Okay, so this is the first page of the lab. Has the objectives, the procedure in it. The procedure is pretty straightforward on collecting the data, and then it's pretty straightforward on the calculations you want to make, and we're going to take a look at those in just a second. Here we talk about just some of the conclusions you get. I want you to graph a plot of the average distance in the x direction, how the average distance that it goes versus the angle. And I want you to see that relationship between firing angle and range or distance that it goes. Okay, so this is the data sheet. You don't really know how long it's taken me to get to this point because the computer is incredibly slow. So there's you're going to do 4 angles, and you're going to run 3 trials at each angle. Information for trial 1, distance goes in there. The corresponding time that it's in the air obviously goes in there. I want you to calculate the average range. So this is our average dx. And you know how to calculate average. And I want you to calculate average time here, and based on your 3 times. So this is our average time. Now, the only x equation we have is dx is equal to vix times time. I want you to do that. I want you to use this equation to calculate our initial velocity and the time, and it goes initial velocity in the x direction, and it goes right there in that box. Keep in mind, and this is working things a little bit backwards, when I give you the initial velocity and angle, the first thing you do is break it up into the x and the y. And the initial velocity in the x is the initial velocity times the cosine of the angle. Well, we know the initial velocity in the x. We know that the angle, so we can get the cosine of the angle. So we can calculate its overall velocity. And that's what I want you to calculate right here. That's the launch velocity, is its overall velocity. We calculate the initial velocity in the y the same old way, using the sine of the angle. This is the time. This is not the same time as the average time. This is the time it takes to get to maximum height. So this is time t to max height. And we've done some sample problems in class where you can calculate that. If you know the velocity in the y, we know g, we know the final velocity at y at maximum height, you can calculate the time it takes to get to maximum height. And then the maximum dy is what is that maximum height. Again, very similar to problems that we've done in class, and you can do that as well. I want those calculations done for each angle. And that, basically the data table is what's due on Monday.